Yeah.
So today we're going to start with midpoints and distance formulas. And basically what we're going to wind up working on, pretty much only thing today, is going to wind up being midpoints. And I don't think we're going to have a ton of time to be able to construct the midpoint today, but we'll probably do that tomorrow and just kind of remind ourselves how we use the tools and stuff. Because we wound up going over a little bit of the extra homework stuff. We didn't go on yesterday, so it's not a big deal. So what I'm looking at here today is basically midpoints. Now you could probably figure out what a midpoint is just from the term midpoint. What do you think the midpoint is? The point in the middle. The halfway spot. Okay? It's the idea that you can take a pencil and balance it in the middle. Half is on one side. Well, obviously this is different because it's got the eraser and the extra piece, but you get the idea that you can balance something through. Fancy. If I take a ruler, that's even a better one. If a ruler is 12 inches long, where do you think the midpoint would be? It would be where, Whiskey? At the 6 inches. Because 6 is half the length of 12.
It is?
I know.
What?
I know. I'm sorry. If you guys must figure out that 6 is half the 12, we do have calculators. We are still selling them. And we can figure that out. Sir.
It doesn't make sense. How is 6 to half of 12?
Well, when you take half of something, you're looking at the idea of what are the two numbers that are exactly the same that you add together to get that number. So if you add 6 plus 6, what do you get?
Wouldn't that be 11?
Stop. So anyway,
Mr.
midpoint.
No,
No, we're done.
I'll figure out the answer. I use a calculator.
There you go.
I did.
Anyway, so a midpoint in geometry terms, you'll see me abbreviate midpoint a lot more as just MDPT. We okay with that? The midpoint of a segment is the point that divides the segment into two congruent segments. Now, when we talk about congruence, remember, congruence just means equal value. So if I have a segment, and I want to say that,
Excuse me.
so if let's say we have segment A, B, and we're going to call X the midpoint. If X is the midpoint, if X is the midpoint of AB, there we go, then AX is congruent to XB. And we just throw little tick marks in. So basically what I'm getting at here, this is going to be kind of what I'm going to call a progression. And this is going to help us later on as we start talking more about proof stuff. If you are ever given a midpoint does what? It divides into two congruent segments. So when you have a midpoint, you always have two congruent segments. So if given midpoint, you state the two congruent segments that are formed. X is a midpoint, therefore AX is congruent to XB. That's the ideas as we start to go on later on in triangles, how the thought process works. Yes, sir.
But you cannot solve for AX unless for XB unless if you know what the whole line is or.
Correct. We don't know. Yeah, if we know one part of it, we know the whole thing. But in generality, if I just state that it is a midpoint, I can definitively state AX is congruent to XB. Pause, put your foot down, please. Yes, sir. Okay? So I can always state that if I know that information, I can always say that this happens, because it always does. Okay? That's what that means. If you're given that info, you can say that. I know something. All right, so here's another one, a segment bisector. A segment bisector is just like a midpoint, but it can be more than one thing. A segment bisector can be a ray, a segment, a line, really anything else. It's a more general term than midpoint. It does the exact same thing, it just can be something besides a point, that's all. So sometimes they will interchange the language between a midpoint or a segment bisector. They do the same thing. It just might say that AB is a segment bisector of XY. That's all. That's really all it means. Okay? What's that?
Oh, what was the midpoint again? It just got my.
It was the a point that divides a segment into two congruent parts. That divides a segment into two congruent parts. Okay. Really, the main thing of this one, guys, is the fact that it can be anything besides a point. That's all. So sometimes you will see in problems, it'll say that there's a ray that bisects something. There is another segment that bisects. That's all it means. I just want you guys to see that a segment bisector does the exact same thing as a midpoint. It still cuts the segment into two equal congruent segments. That's all. All right. So they're kind of, well, they kind of go hand in hand with each other. Now I'm saying that, I'm trying to think in this section if segment bisector is shown a lot. I think if they're just prepping them for triangles. Because in a triangle, a lot of times it'll say like the ray AB is the bisector
Right.
of BC.
Right. So the vocabulary is important.
Yeah. We okay on that one, guys?
No.
Excuse me. All right. So here's what happens. Goes back to the idea of X is the midpoint of AB. Mrs. Thrower had a great question for me a second ago. Shouldn't there be segment notation on my lettering? When I was saying segment AB, shouldn't I put a bar above it? Technically, yes. Is it the end of the world if we don't? Not. We're talking about segments. It's really not that big of a deal. The way that we've revamped some of the stuff as we get on later on, when we do work with I almost said do proofs. I almost said do. But when we do work with some proof stuff, I'm trying to alleviate some of the issues about switching equality congruency within the segments and the notation. So if you guys forget about the idea of putting the bar above that, I'm not going to really cry. I might be sad, but I won't cry. Yeah. So think about the idea here again. If X is a midpoint, it cuts the whole segment AB into two equal congruent parts. So that means that AX has to be equal to XB. So I know that AX is congruent to XB. But when we do math, when we solve equations and stuff like that, we solve equations in terms of equality. So when we said things were congruent, remember, it means the same as equal length. It means the same thing as equal length, so then I can say AX equals XB. Well, in this problem, what did AX equal? Actually, if I should blow it up so you can see it better. So 4x minus 1 has to equal 3x plus 3. And now we have enough information to solve for x, and then we can solve for the lengths of the segments. It's a quick two-step problem. You have variables on both sides of your equation. Pick out the little guy. Who are you going to move? Hey, let's stop doing that and write problems. Thanks. Move the 3x. Very good. And can I move the negative 1 at the same time by adding it? Are you okay with that? So x is 4. So if x is 4, all we have to do then to figure out we can find out the 3 different lengths of segments is to go ahead and substitute back in. What is 4 times 4? What's 16 minus 1? So ax is, so if I math correctly, the other side should also have to equal, so we check it. What is 3 times 4?
3 times 4 is 12.
What's 12 plus 3?
15.
Did we
123.
Did we wind up with the same spot, same parts? Which means what is the whole? 30. That's the kind of stuff we're doing, guys. Really, really straightforward, don't you think? Let's try another one. There's actually a technical formula for when you're dealing with coordinates. And what I mean by coordinates, we're talking about ordered pairs. One set of x and y values, and another set of x and y values. And this is actually really, really easy. And I know you've seen this before. You got any cash on you? You got any cash on you?
I do.
How much you got? You got $10, $5? What?
Let me check. Shoot, I forgot to get the rest of
Oh,
my
no big
check
deal.
was
How much you got on you?
yesterday.
You got 20? Hey, this works out great because I have 41 bucks. Why I have $41 beyond me, I'm surprised I actually have cash.
What
I
are you
never had
thinking?
cash. So let's say we wanted to figure out what the average amount of money is between the two of us. How do you find an average? Yeah, we add them together and divide it by 2. So if we're looking at the money that we have, I have $41.
Add some more.
And you have, would you say you had a 20? Bless you.
So you
Add some money.
have 61 altogether.
So we have 61 bucks together, right? What's the average of 60 between the two of us? What would you do?
Divided by 2.
Divided by 2. So if I take half of 61, what do we get?
30.2 or 30.5.
So we averaged out at $30.50 between the two of us. That's our average. Isn't that the halfway point between our two values? That's all midpoint is, guys. It's finding the average of two numbers. That's it. So when you think about ordered pairs, when you look at ordered pairs, there's one x value, there's the other x value. You're finding the average of the x values. You're finding the average of the y values. That gives you your midpoint. Always. Always, always. So the midpoint formula is nothing more than taking the x values, adding them together, divided by 2. Take the y values, add them together, and divide by 2. This then creates a separate x and y coordinate that we would call xm for, what do you think?
Midpoint.
Midpoint, and the y midpoint. That's what this creates. So when we walk through a problem then, all you have to be able to do is identify what your coordinates are. Now, when you're talking about coordinates, what comes first, x or y? X. Now, x's, are they the left and rights or are they the up and downs? Left and rights. Okay. So, when we're looking at this, I'm going to look at my ordered pairs. So I have a -4 and a +2 for one of my ordered pairs. Let me do this so I have space. I'll blow this back up. So one of my ordered pairs is at -4 and +2. My other one was at 3 and 6. Really, all I have to do, pop this off here. All I have to do now, and the easiest way to do this, is to label them again. First x value, first y value, second x value, second y value. And then I go through the formula. My midpoints,
It's -1,
the midpoint, oops,
it's -1.
hold on one second. It's going to be first plus the second divided by 2, comma, first plus the second divided by 2.
Alright, for the x, you got, I got -1.
Hold on. So we fill in the blanks. We have -4 plus 3 divided by 2, comma, 2 plus 6 divided by 2. Now here's where it becomes pretty important that if you're going to put this in a calculator, that you utilize that fraction bar. So for those of you guys that just have gotten that multi-view calculator in the past couple of days, this is gold. The fraction bar is gold. The fraction bar is gold. So, if I make a fraction bar, whether it's my calculator like this, or yours with the N over D button, press that one. Now, I know you have the 84 also. It's John, right? Look at me, you remember names, yes. Do you have the newer operating system on that where you hit alpha y equals, and does it come up? Okay, cool. If you hit alpha zoom, does it come up with other options also? I'm just wondering. Is this like rows and stuff? Okay, so yours is up to date, cool. So in this case here, what I'm going to do is I can literally put in this whole midpoint formula and get it right each time. -4 plus 3 over 2. Boom. Where's my x midpoint? -½ I do the same thing. Alpha y equals for mine 2 plus 6 over 2. It's at 4. So my midpoint then is located -½ and 4. And that's how that works. Because here's the deal. Watch what happens if you don't use the fraction bar. -4 plus 3 divided by 2.
What did the calculator do then with that?
Divided first, very good. It went order of operations, divided first. But by utilizing the fraction bar, it won't do that, okay? That's the big deal with the fraction bar. It's huge. If you don't have a calculator with the fraction bar, I highly recommend getting the one. Otherwise, with the one that you have a fraction bar in yours, right? I thought. Yeah, so usually gonna be all right, okay? If you don't have that, would anybody else not have the fraction bar? Like the old, just the regular TI-34s or whatever we
Do
want?
any of you have an ABC button? Says ABC?
That one, or if you
Is that-
group it with parentheses,
Yeah.
but you gotta, I'm gonna say one thing here though, is that we're gonna wanna keep fractions. Fractions are gonna be much easier to work with in the long run. We utilize fractions so much more in Algebra 2 than anything as we go through. Let's try one more of these before we run out of too much time. And we'll probably have to go to the find the missing coordinate tomorrow. So let's see, we have -3, -4, and 6 and -6. And I'd like you guys to take a second and find the midpoint. Okay, let's find the midpoint. Midpoint formula is something you're gonna have to remember. On this one? Yeah, yeah. Nope.
You got a fraction, leave it as an improper fraction, don't change it to the next number.
So since we're running really short here, let's check. We have -3 plus 6 over 2, and then -4 plus -6 over 2. The x-coordinate is 3/2, and the y-coordinate is -5. I'm hoping everybody got that?
Yeah.
Now, watch what happens then. If you graph that, 3/2 is 1.5.
Yeah.
I know you don't do a lot of graphs and stuff like that, because I'm not giving you guys graph paper to worry about this, but just take a look. If I'm at 1.5 and 5, doesn't that, I mean, just for argument's sake, doesn't that kind of appear as though it would be a nice midpoint? Yes. What I would like you guys to work on this evening is on page 19. And let's just start with, 8 through 22 evens, please. Okay? Let's start with those for tonight, and then we'll work our way out of it with some more of, tomorrow we'll do find the missing endpoint, which we don't do anything but count. That's all I do. I don't do the other stuff. No
You
way.
don't do the-
No.
This number
No.
equals this plus x
Nope.
divided by 2.
Nope.
multiplied
Why?
by- Right.
If you are here and you are here, this is 3 to 7, 4 to -2. From 3 to 7, you go up or down. Yep. You go up or down. How many? What's 4 more than 7? Yes. From 4 to -2, you go up or down. No. What's the point? What's the point? Count. Count.
Wow.
Yep. Sir.
And then they can see that.
Yes, please. Yes, sir. Yes.
Wow.
Yeah, that's all that is. I stay away from all the